Hello, college math. Happy Friday, you guys. I'm so sorry I'm not in class today, but I still wanted to make sure that you understood this lesson, okay? It's called Lesson 4.6, Applications of Logs, okay? Hopefully you guys have all gotten to here. If you haven't, just a reminder, you got this under Canvas, Modules, Unit 4, okay, and it's 4.6 in class notes. Also a reminder, you want to make sure that you're logged in under your school account to access this Google form, okay? So, and also a reminder, if at any time I'm going too fast, pause me, rewind me, do whatever you have to do, okay? So first and foremost, I need your email address. I think it automatically collects it for you, and make sure you put in your last name. Okay, so what I'm going to be doing, let me flip this so we can see it all. I'm going to be doing every other problem to teach you. So we're going to look at this first one, okay? The first one is, it reads, the population in millions of a certain country can be approximated by the function below, where X is the number of years since 2000. Okay, we did one of these the other day, I think. In which year will the population reach 75 million? Okay, so this is our original equation. And this P of X, I want to know when it's going to reach 75 million. Okay, so we are looking for X. We want to find X. All right, so here we go. Let's plug in what we have. We have 75 equals 50 times 1.03 to the x power, okay? And if you remember, whenever you have the exponent is the unknown, you want to get it by itself. So the first thing we're going to do, we're going to divide both sides by 50. Okay, 75 divided by 50, let me move over here, gives us 1.5. Okay, 1.5 is equal to 1.03 to the x power. Okay. Now, in order to bring that exponent down, hopefully you recall that we need to take the log of both sides. So I'm going to go log 1.5 equals log 1.03 to the x. Okay. That ends up dropping that exponent down. Okay. So I'm going to just do that all in one step here. So I have x log 1.03. Next, all we got to do to get x alone is we're going to divide both sides by the log of 1.03. Okay. And in doing so, you're going to take your calculators and most likely pause me right now to do that. And if you stick it in your calculator, you're going to get that x is approximately 13.7. Okay. This is not the answer. Okay. 13.7 is not the answer. I want the answer. I wanted to know in which year, okay, in which year will the population reach 75 million? Okay, so the X is 13.7. This just tells me that it's 13.7 years after 2000. Okay, so we take 2000 and add that 13.7 to it. And I know we get 2013.7, but we never talk about years as 2013.7. Like right now it's December of 2020. I'm not going to say, yeah, we're in 2020.9. Okay, no, we're still in 2020. So our final answer here is going to be 2013. Okay, so in your Google form, you are going to type in the year 2013, and then you're going to try to do number 4 on your own, okay? Just a reminder, you can pause me if I'm going too fast, okay? The next problem, okay, that I'm going to do with you is air pressure, okay? It says air pressure may be represented as a function of height in meters above the surface of the earth as shown below. In this function, P0, okay, P0, that's right here, is the air pressure at the surface of the earth, and H is the height above the surface of the earth, measured in meters. At what height will the air pressure equal 75% of the air pressure at the surface of the Earth? Okay, you should pause me and read it again to yourself. Okay, so I want anytime you see a zero, a P0, this is like your original starting point. Okay, so this happens to be the air pressure on Earth. Okay, so I want to know at what height. Okay, so I'm going to be looking for H. Okay, at what height will the air pressure be 75% of the air pressure on Earth? Okay, so P of H, that is going to be 75% of the original air pressure. I don't know what the original air pressure is, so I'm just going to call it 1. Okay, because it could be 75% of anything, it's still going to be 75%. Okay, so we're going to plug this in, and we get 0.75 equals 1e to the negative 0.00012 h power. Okay. Now, in this problem, since it's a 1e, I don't have to divide both sides by 1. I'm still going to get the same equation. However, anytime we talk about e, okay, I don't take the log of both sides, okay? I'm going to take the natural log of both sides. So when I take the natural log of 0.75 equals the natural log of e to the negative 0.00012 h, okay? The thing that happens here is because the natural log has a base of e, okay, this all cancels out and it simplifies the problem. Okay, so now I've got the natural log of 0.75 equals negative 0.00012 h. So many zeros. Okay. So again, because the natural log has a base e, these guys cancel out. Okay. Now, to keep going, we need to solve for h, so I'm going to divide both sides by negative 0.00012. Okay. Don't forget to use that negative sign. Okay. You can pause me to find this on your calculator. You need to know how to do this on your own. Okay, you hit natural log 0.75, divide that by negative tiny little number, and we get that h is 4256.9. Okay, it's 4,256.9 meters. Okay, you're just going to put in your answers on the Google form, just type it in 4256.9. Okay, you don't have to label it with meters. Okay, now you're going to try number 6 on your own. Okay, try 6 on your own. Okay. All right, now the next one, savings accounts. Okay, we've talked about savings accounts, but not about savings being compounded continuously. Okay, so I want to give you a formula that you need for interest compounded continuously. Whoops. Compounded continuously. Okay, and that formula is A equals P times E to the RT power. Okay, P times E to the RT power. We refer to this as PERT a lot of the time. Okay, and A is the amount of money you're going to have after T years, or the amount of money you're going to owe after T years, depending on what kind of a problem it is. P is the principal, the amount you start with. Okay, E is very important. It's the button on your calculator. Okay, you have this button on your calculator, and it looks like e to the x. Okay, e to the x. And you'll be taking e to the x power, but in this case, you'll be taking it to the RT power. Okay, where R is your interest rate, and T is time in years. Okay, T is time in years. All right, so knowing this, okay, the next problem says, if you were to place $4,500 in a savings account that pays 10% interest compounded continuously, okay, that tells you you're going to use this formula, how much money will you have after 5 years, assuming you don't take any money out and you don't put any more in? Okay, so after 5 years, how much money will you have? Okay, well, I know that P is 4,500. I know that R is not 10, it is 0.10 or 0.1, and T is going to be 5. Okay, and we're looking for A. So let's plug it in. A equals 4,500 times E to the 0.10 times 5 power. Okay. Now, it's a bummer that I'm not here because I really want to show you how to use this on your calculator. If you have a regular calculator, you're just going to type it in exactly as you see it. 4,500 times, you have to activate your E to the X button. Once you do, you just type in 0.1 times 5. Okay. Now, if you have a phone calculator, okay, if you're using your phone calculator, you're going to first do 0.1 or 0.10 times 5. Then you're going to hit the E to the X button. Okay. Then you're going to hit the E to the X button. And then you're going to multiply that by 4,500. Okay. And once you do, your answer is going to be $7,419.25 because it's rounded. $7,419.25. Okay. So in your Google form, you're going to write 7419.25. Okay. Anytime we're talking about money, we use money language. So 25 cents, right? You're not going to do 0.3 cents. Okay. It's 25 cents. Okay. You're going to try the next one on your own. Okay. And then we're going to move on to number 9. Well, on my paper, it's 9. Okay. So the next one says that the original purchase price of a car is $30,000. Each year, its value depreciates, okay, by 15%. 4 years after its purchase, what is the value of the car? Okay. So for this problem, we've actually done one of these before. Okay. I'm going to remind you. We know that at the very beginning, our original purchase price is $30,000. Okay, and every year it goes down by 15%. So that means every year it is worth 85% of its original value. Okay, so I want you to think after 1 year, it's going to be worth 30,000 times 85%. Why? Because 100% minus 15% is 85%. Okay, then the following year, it's going to be this amount times another 0.85. And then it's going to be that amount times another 0.85. You get the idea. Okay, so our common ratio is 0.85. How do I know it's a common ratio? Well, because this is a geometric sequence. Okay, because we keep multiplying by 0.85. So if I want to know, if I want to know what its worth is 4 years after its purchase, okay, let's go back. I purchased it for $30,000. After the first year, I have 30,000 times 0.85. Then I have after the second year, the third year, and the fourth year. So we are really going to find A5. Okay, we're really going to find A5. And we're going to use the formula AN equals A1 times R to the N minus 1 power. Okay, this is the formula we use. So here we go. If I want to find A5, I'm going to use A1 times R to the 5 minus 1 power. Or A5 equals 30,000 times 0.85 to the 4th power. Okay. You're going to use your calculators to find A5, and I get that car is now worth $15,660.19. Okay, $15,660.19. Okay, again, it's money, so you're using that 19 cents. Okay, and of course, you're going to try the next one on your own. Okay. All right, so ladies and gentlemen, that's it for the notes today. Okay, your assignment today. Okay, there is no quiz, no Apex quiz today. This counts as your quiz. Okay, you have to complete this entire thing. Okay, complete this form, submit it, and that's your quiz for the day. Okay, then, okay, I know the sub already told you, then you're going to go and you're going to look at the Unit 4 test review. Okay, it's going to be on the bottom of modules Unit 4. Okay, and there are 20 questions to this review. You do not have to do all 20 by Monday. Okay, however, by Monday, I want you to have try at least one problem of each kind. One problem of each type, because I'm going to go over all of these questions on Monday. Okay, and then next Wednesday, you have a Unit 4 test. Okay, so if you have any questions, email me, ask each other. If you didn't understand some of this, rewind, okay? And I hope you guys have a great, great rest of the day and a fantastic weekend. I will see you guys all on Monday. Bye.